members. Luigi Sapitelli is a senior reservoir engineer and applied to ADNOC having 25 years of experience. Worked with various operators and service companies around the world. Founding member of Real-Time Optimization PIG and Petroleum Level Analytics Technical Section. And he is the recipient of the 2015 International Production Innovation Award. He has published more than 80 industry papers on applied technologies related to reservoir management, real-time optimization, and production operations. Mr. Sapitelli is an electronic engineer with a master's degree in chemical engineering and a PhD in chemical engineering. He serves as managing partner in Frontender, which is a petroleum engineering service company based in Houston, USA. Please go ahead, PG.
Thank you very much. Good morning, everyone. Good afternoon already. It was an excellent introduction from Navid in the previous presentation, so that I can save a lot of slides on the introduction of the BPM technology. So this time we'll focus in another application using a similar technology, but for integrated reservoir management. I'd like to acknowledge all the co-authors from ADNOC, Frontender, and Halliburton. So the agenda for today is going to cover some of the goals and challenges of what we call the reservoir performance reviews, the role of IRM and business process management in these reviews, and then we go over one solution that we did for one of the larger offshore assets in Abu Dhabi. So as explained before in the previous talk, and as you may know, reservoir health, the only future that we can predict is that it will deteriorate, either by pressure decline and natural depletion of the reservoir, or as given by the exploitation plan, or it will decline because of unplanned events, as previously discussed, inactive strings, field problems, etc. Reservoir management is just that practice, is continuous practice of identifying the opportunities to enhance and arrest this decline. The reviews, which has been also explained in the previous two talks, continuous reviews of a multidisciplinary team are key to maintain these reservoirs' health at the optimum stage. We do field reviews, additional, sometimes we call it major field reviews, sometimes we call it decision compressor cycle, redevelopment cycles, etc. The idea is to handle from high frequency to low frequency in multi-year, a decision review cycle of what is going on, what is working, what needs to be expanded in our fields. So the objective of this work is to show you how to automate directly the collaboration of multiple disciplines in the performance review, while ensuring the consistency of the results. We'll show a little bit what are the challenges that these teams often have, and how we can help not just the review of one asset, but sometimes there are assets that are huge, that we cannot spend time reviewing on a yearly basis the whole asset, because they are so huge that they need to have an immense amount of resources. But instead, we focus on the most important actions and the most important exception base every year. So what are performance reviews? So these are tasks that can be either continuously planned or ad hoc on a continuous basis to integrate the understanding of the conditions of the reservoir. So basically it's to assess continuously, update the reservoir characterization, update the dynamic synthesis, in order to review, are my constraints still valid? Can I change my guidelines? Can I change my well allocation? How am I going to continue redevelopment? Am I targeting my expected long-term recovery, etc.? And to continuously have these opportunities for improvement. Typically, we work into the typical plan for well replacement, sometimes due to integrity issues, sometimes we look into the new artificial lift, sometimes we look at the redevelopment, readjustment of dejection schemes, etc., by comparing with multiple options. So the goal of this review is to promote an environment so that analysis and decisions, surveillance data is integrated in order to promote the identification of innovative solutions to challenge the status quo, to reshape the status quo, etc. And the objective of the business is clear: it's continuously reduce the unit production cost, to enhance the performance of all the screens, to enhance my water injection efficiency, etc. So what we call enhance or prolong the health of the reservoir. The challenges, typically, I'm not going to spend too much about this, but you may be familiar with and seen data avalanche, rapid increase as we bring more sensors, we bring more data. On one sense, it's impossible for the teams to ingest and digest all this data, but on the other side, there is also the problem of multiple data that is not enough. So on one side, we have too much data that we can analyze. On another time, we complain about having not enough data. Sometimes we get lost in translation by having multiple disciplines talking in the same environment, coming from different companies, coming from different level of experience. Sometimes the consistency to achieve particular elements are not captured. Also, low value added tasks. Most of the time we spend a lot of time and effort in preparing the data and massaging the data to make it usable. The variety of the data in terms of formats, domain, data structures, multiple timescales. So we have some of the data comes on a high frequency second-to-second data. Sometimes we get long. And the most common problem, which is described in the previous talk about the governance, the lack of ownership, who is accountable for certain decisions, and the traceability of all the decisions from the idea generation to the execution and evaluation of the processes. So all these challenges have been addressed in the form of a series of guidelines and assessment through the IRM framework from ADNOC, where the process is to have a series of standard processes from data acquisition, generation, integration, opportunity generation, and execution monitoring on a consistent manner. The expected outcome is to have more efficiency in all the processes, smart decision making, knowledge sharing and standardization, and in general rely on a consistent set of guidelines for the organization. But as previously explained, how do we keep consistency in just having a document stored in the shelves and not being a practicality in the real life? So there comes the use of a common, let's say, very well used technology in other industries. We brought it into the oil and gas. So the BPM is just this discipline of technology that allows the integration, design, modeling, automating, execution, control, and measurement of all the activities around a business process. It's just a combination of the activities from and linking people to the system and system to the people, so that the byproduct generated by the interaction between people can also be used as a new sources of data. For example, the timing that I take to respond, the approvals, the verifications, the controls, the cycles, etc. And providing all the options so that the workflow is reconfigured as per the need of every, let's say, surveillance exception based. So the process that we're working in this problem is about the sector performance review. So this is the high level of the process. It follows the 6 milestones of IRM, from the data gathering, validation, analysis, integration, opportunity generation. We are looking here at the main player, which is the reservoir management unit, where there is in the process of initiation, which may include many tasks in particular, from defining the objectives of the review, or defining the disciplines that will be involved in the review, and defining the KPIs of that particular review. The data sources are connected directly to the KPIs generated. We'll see the architecture in a minute. And then in here, this swim lane, we call functional group, may be represented by 5 to 8 different disciplines, from reservoir geologists, geophysicists, petrophysicists, petroleum engineering, production accounting, integrity, etc., depending on the workflow that is being executed on every time. So on the data gathering, evaluation and query reservoir data and data analysis, so these are activities that are guided through the workflow, especially for young engineers, how the data needs to be analyzed, what do we expect from a particular diagnostic plot, what do we expect from what happens if a KPI is deviated from the target. So the workflow is to analyze and compare and provide the guidance through any engineer in the same fashion every time, all the time. At the end, we go back to the second core team meeting review where the data is analyzed, the opportunities are treated, and the opportunity and risk management of the reservoir are stored in a common database, which is followed in another process. And at the end, we close the review. So this process, which used to take typically from 3 to 4 months on a particular small reservoir, can be streamlined and repeated on a given consistency. So the architecture of the solution that we implemented in this complex offshore assets is we access the common data sources from production volume, event status, reservoirs definitions, logs, business plans, and all the disparate data sources. We implemented an ETL layer where all the KPIs are continuously calculated and store this into analytical database for the system. Then the visualization is used commercial off-the-shelf tools as Spotfire, and we also link to our GIS server where the data from the maps are captured and integrated into the same environment. Then we use the BPM engine where that is also an off-the-shelf application, and both of them integrated into a user authenticated web access. So given this architecture, we provide a series of features that can be very streamlined and provided to the asset. For example, standardizing the automated business process, not just IRM, but any other of the processes like shown in the previous presentation, automating the data gathering and validation and analysis workflow via, so all the data that is run can be easily interchanged with the IT and data management so that it can be assessed, reassessed, and put back into the database. Tracking and measuring the monitoring, the gathering of all the historical recommendations of the asset, providing guidance to young engineers about the best practices and how to use the data, how to interpret diagnostic plots, and maximizing the use of the corporate data in the multiple areas. This is one example of the visualization that it comes in an automatic fashion from the integration of maps generated in the geomodeling packages, traditional one brought through the GIS CMAP format, the production injection, the reservoir health KPIs. There was a paper yesterday going in details into these KPIs, pressures and VRR. Then we also have an overall dashboard that's looking to the health of all the individuals' reservoirs and looking into the particular sorting and analysis and linking. So from these screens, we can trigger workflows by exception if any of the particular areas is highlighted, bringing the pressures and VRR calculations and saturation maps. So there is about 100,000 calculations of the data done for every asset on an overnight basis, just to compute the KPIs that happen on particular areas to highlight predictive KPIs highlighting areas of interest. There is another visualization example, so we bring a lot of the visibility of the results of the geomodeling packages, the simulation packages. So typical maps like saturation, pressure, residual oil saturation, and oil movement at the reservoir level can be integrated with the surface data. Okay. So this is an example of the opportunity and risk registry. So basically, assets are, any user is able to add and include opportunities and track them in relationship to a particular asset. And the plots and the combination of the different surveillance data is included into the business process management itself. So in general, the benefits perceived of this implementation, we have improved and given the consistency of all the execution of reservoir performance reviews to one asset, but by doing the cookie cutter and accessing the same database, we are going and implementing and rolling out into 4 new assets in this during this quarter, and the plan is to fully roll out to all the assets of ADNOC by the year 2019. Protecting the integrity of the reservoir because we are proactively accessing and repeating this review on a consistent basis. we are ensuring that all the opportunities are captured and followed up and integrated directly into the business plans on a continuous basis. And the whole process allows us to monitor the variance of all the plan and actual performance of the business plan and yearly reviews. In conclusion, as we presented here, BPM, through this Reservoir Performance Review, we offer a new way and collaborative way where we can embed the digital transformation of one people process into the existing system. So we are not building a new system, we are not building a new legacy system, we're just giving visibility to the existing data, and we are making sure that the collaboration between the different disciplines is guaranteed, is tracked, and all the collaboration generates a data that is valuable as a byproduct to be used into the future analysis. We're able to track the success of the actions back to the original decisions, and as previously mentioned, this process is built in a way that can be configured and improved on a continuous basis. BPM tool by itself generates internal KPIs about the efficiency of the tool, the time it takes, where are the bottlenecks, which process can be improved, and the process is, the only thing that is changing the only thing that is constant is the change, it's continuous improvement. Okay? Thank you very much. I'll be glad to answer any question.
Thank you. Floor is open for 5 minutes.
Yeah, thank you for a good presentation you've made. I want to find out what is the connection between Express and the data you are gathering for this particular BPM. Is it linked to Express or not?
Yes, Express is one of the corporate data sources that we include in here. So we bring data, not just the one available in Express, from all the daily operations, we call it the extensive model, and we access through something called the Upstream Data Hub. So Express is one of the sources that is well established within the ADNOC group, and we are expanding through more sources.
Other questions? Go ahead. Yeah, on the floor. Oh, sorry, the lady in the back.
Excellent presentation, Luigi. I'm glad to see that we are having evolution in this process of IRM and having this business management. The question is particularly for the risk registry. What method has been used in order to make it easier to quantify the risk, to load it in the system?
Okay, for every opportunity at this time on the first version of the software, we just capture the risk of all the reservoirs and assets using the traditional ADNOC method, which is based on ISO 31000. And we have the typical qualifications of this risk available. In the